All right, geometry, it's day 20. This is the last video you'll have to watch. I know you're so sad. I'm so sad too. Went by fast. All right, so let's look at today's. You're going to be starting off with giving 2 points, and you're told to give the equation of that line in slope-intercept form. So to do that, we're going to use a couple of different equations. We're going to use this one a lot during this lesson. This is point slope form. Y minus y1 equals m times x minus x1. And so we're going to start off with our points, and we're going to start off by finding the slope between those lines. So x1, y1, and x2, y2. So I'm going to start off with my slope. And this is slope formula. Okay, m equals y2 minus y1 over x2 minus x1. And I'm going to substitute in these points into that formula. So this is going to give me, I'm going to start with y2. y2 is 3 minus y1, and y1 is a negative 3. So minus a negative 3 over x2. x2 is 1 minus x1, which is 2. Okay, so whenever I do this, that minus minus right there, that 3 minus a negative 3, combines and makes that a plus. And 3 plus 3 is 6. 1 minus 2 is a negative 1. And 6 divided by negative 1 is a negative 6. Okay, so I know that my slope between these two lines is a negative 6. Okay, so now I'm going to start on my actual equation. Once you get your slope, you can start on your equation, and we'll use this formula, this point slope formula up here. So y and x in these, those stay the same because remember slope slope-intercept form has y equals mx plus b. So y and x are going to stay the same. We're going to substitute in for y1, m, and x1. So y minus, okay? Now whenever we do this, we can use either point. It does not matter. If you want to go ahead and use the point that has x1, y1 labeled in it, that's perfectly okay, but you could also use this point and you'll get the same end result, the same end answer. But I'm going to go ahead and use this x1, y1 right here. So y minus y1. Well, y1 is negative 3. So if I have y minus a negative 3, that makes that a plus. So plus 3 equals my slope, which is my m, is negative 6 times x minus x1, and x1 is 2. Okay, I've done all my substitutions. I'm done with these points and slope. I'm just going to focus on this now. I'm going to distribute my negative 6 through my parentheses. So y plus 3 equals negative 6x plus 12, because negative 6 times a negative 2 is a positive 12. I'm going to subtract 3 from both sides. And y equals negative 6x plus 9. Now that is in slope-intercept form. Y equals mx plus b, where negative 6 is your slope, 9 is your y-intercept. So if I were to graph this line, it would go through these 2 points. Fancy. Okay, so let's look at if we're just given our equation. We didn't have to worry about slope or anything like that. We've just given our equation. This is in point slope form. We have to convert it to slope-intercept form. So we're going to do the same thing like we did in the last problem. We're going to start off by distributing this negative 3 halves through our parentheses. So y plus 2 equals negative 3 halves times an x is a negative 3 halves x, and negative 3 halves times negative 4. So whenever we're multiplying fractions times a whole number, we're going to multiply the top of our fraction times our whole number, and then divide by the denominator. So numerator times whole number divided by denominator. And this is a negative times a negative, so my answer is going to be positive. 3 times 4 is 12, and 12 divided by 2 is 6. Okay, now I'm going to subtract my 2 from both sides. So y equals negative 3/2 x plus 4. And this is in slope-intercept form, y equals mx plus b. So these two equations are equivalent to one another. This is point-slope form of the equation. This is slope-intercept form of the equation. All right, so let's look at parallel and perpendicular lines. We're going to write an equation. This is the symbol for parallel. If you don't remember, this is parallel. So an equation that is parallel to this equation. So I'm writing an equation that is parallel to this equation and goes through the point negative 3, 4. Okay? So let's start out with what we need. We're using this point slope form, so we need our slope and we have our point. This is our x1, y1. And if I want it parallel to this equation, then I want the two lines to have the same slope. So I'm going to look at this equation right here and determine what the slope is. Well, if this is in slope-intercept, y equals mx plus b, then I'm looking for my m, which is my slope right there. And I want them to have the same slope, so I'm going to use the same slope as this equation. So I'm going to use 2 for my slope. Here's my x1, y1, and I'm going to plug it into this equation out up here. Y minus y1, so y1 is 4, equals m, I'm using the slope of 2 because I want them to be parallel, times x minus x1. So x minus x1, x1 is a negative 3, so it makes it a positive 3. I'm going to distribute my 2. So y minus 4 equals 2x plus 6. I'm going to add 4 to both sides. And y equals 2x plus 10. So now this equation here, y equals 2x minus 6, and this equation, y equals 2x plus 10, those are parallel to one another. This equation, though, will go through the point negative 3, 4. All right, and lastly, we're going to do an equation that is perpendicular to another. So I need to write an equation that is perpendicular, it's a symbol for perpendicular, to y equals 5/2 x plus 3. So this is my original equation, and I want it to go through the point 4, 0. Okay, this is still my x1, y1, 4, 0 is still x1, y1. But I need to look at my slope. I need to figure out what slope I'm using. Well, right here is my slope, okay? So my m is 5/2. But since I want this to be perpendicular and not parallel, I'm going to have to do something to the slope. Now, if it were parallel, I would use the same slope. But since it's not, I want one that's perpendicular, I have to use what is the opposite reciprocal slope. So the opposite reciprocal of 5/2. That just means if it's positive, I'm going to make it negative. Or if it's negative, I'm going to make it positive. And then I'm going to flip my fraction. So now, instead of using 5/2, I'm going to use negative 2/5. That's the slope that I want to use for a perpendicular line to this one. That is the opposite reciprocal of this one. So I've just made it a negative and then flipped the fraction. Negative 2/5. So now that I know the slope I'm going to use and I know the point I'm going to use, I'm going to sub that in up here into my point slope form. So y minus y1, y1 is 0, so just y minus 0 equals m. Remember, I'm using this slope, negative 2/5, times x minus x1, and x1 is 4. Okay? I'm going to distribute my negative 2/5 through my parentheses. So since this is minus 0, that's not going to matter. I'm just going to drop it off. Y equals negative 2/5 x. And this is a negative times a negative, so my answer is going to be positive. I'm going to take the numerator times the whole number. 2 times 4 is 8, divided by the denominator, which is 5. So that doesn't reduce. 8 over 5, or 8 divided by 5, does not reduce. So I'm going to leave that as 8/5. Okay? And since I don't have anything over here with my y, it's all by itself. This is my slope-intercept form that is perpendicular to this one. And if I were to graph this line, it would go through the point 4, 0. All right, day 20. So excited. I miss you guys. I wish you well. Wish I could see you. I can too. They're in my heart. I see them there. Rotten children.